Our next guest, Paola Branduardi, or Branduardi even, joins us from Milan, I believe. So we'll just bring her into the call. And she's here to talk to us about a very, very hardy and tough yeast. So we'll just check we can hear and see her.
Hi, can you hear me?
Yeah, we can. How are you doing, Paola?
Good morning.
Good morning. Happy International Microorganism Day.
Thank you. Same for you.
So you're here today to talk to us about a very, tough, hardy, bizarre yeast. And I'm going to let you get on with it because you're the expert here. But you're going to give us a very fascinating talk and then stick around at the end to just chat about fermented food in the final few minutes of the breakfast show. But I just want to check with you, have you had your breakfast this morning?
Not yet.
No. What will you eat when you get round to it?
Yeah, I don't know, but yeah, I mean, it was a good opportunity anyhow. And so, when you wait a little bit longer, then you will enjoy even better. So
Yeah.
this is what
Fair
I
enough.
will do later on.
So,
And
I had cheese.
I also have to attend a project, so they will. Okay.
Cool. Okay. Well, let's pop ourselves.
I did the same. I saved my breakfast for after the show.
Yeah, and then you will really deserve it.
Forward to it, exactly.
Nice. Okay. Well, we'll get out your way, Paola. And if you want to share your screen, if you have slides, then you can tell us all about this yeast.
Yeah. Well, thank you. And let's see. I mean, I have some slides, but let's see how it goes. I mean, I'm also in your hands because, yes, I want to talk about this yeast, but also, I mean, you said before, it's also a story of a yeast and a human. So, it's really connected in a sense. And you said before that I'm expert in this yeast. I would say more that I'm beginners with this yeast because I keep on learning from this yeast every day. So I'm not sure I'm really an expert because it's.
But compared to others, it's 20 years we are laughing
it's only
about
that
that sentence.
Putting me
I love the modesty of scientists.
More or less every day. So this is why maybe. Yes, sorry. Yeah, you were a little bit frozen. Yeah, maybe it's my connection.
I think we have you back. Yeah, you froze a little bit, but we have you again. But like I said, I love how modest scientists will be. They'll study something for 35 years and be like, oh, I'm just a beginner in this subject. Forgetting, of course, that no one has anywhere close to the knowledge that you have about this organism. So let me see if I can pronounce the name of this organism. So is it Zygosaccharomyces bailii?
Yeah, or bailii. I don't know,
okay.
But bailii, yes, it's only. I mean, it's all accepted. Let's put it in this way. He, in a sense, I mean, he will not complain. So no, but what I want to say also is that let's say very often with a microbiologist, it's also, well, let's say I talk about me now. It's a story of prejudice also. And I want to shortly say that I became a microbiologist despite my initial idea. And so this is what I think I like most of my job now, because it was a discovery. It was like, serendipity. I would have never guessed to be so fascinated about a microorganism. I was studying, let's say, the development and differentiation of neuronal systems before approaching to yeast. And so for me, it was just a continuous discovery. And then the part on metabolism came in the scenario even later. And that was also another discovery. So what I'm saying is that what I like about microorganisms is that they put myself in front of my tendency to have prejudice, despite I'm thinking that I'm an open person. And so this is what I like most of my job. So just let's say a message that I wanted to give you. And yes, so I mean, I can also try to show my screen because, yeah, I don't know if you can. Yeah, I don't know, but I prepared that.
Oh, wicked. Yeah, we can see those well.
You can see my, yeah. So,
Yes,
but
I do.
I mean, yeah, I prepared that just because, the story with me with this yeast, it's also a story of friendship because of this yeast, I met Michael. So in a sense, I have to say that the first picture is for him because we always laughed a lot about the point that this yeast has been isolated from pickles. And for us, it was always very funny. And indeed, because this is known as a spoilage yeast. So it was also isolated from other food. And then you might say that our initial question of having breakfast with Zygosaccharomyces bailii maybe is not a good idea because it will spoil our breakfast very soon, in a sense. And it can also spoil our evening, let's say, pleasure moments, because it can also spoil wine. You know what I mean? So then this is how it starts. And also, this is why I said it's also a story of prejudice, because, this is only our vision of a story. I mean, this yeast is happy when it's spoiling our food because it's eating. And so obviously, if you stop thinking about the damage that you have to your food, to your drinks, then you would say, yeah, this is a bad yeast. And, it's always obviously an attitude that you can have with many microorganisms, because first you think that they are dangerous or they can bring some, pathology and so on. But in a sense, this is also nice because if you isolate this pre-concept from that, you might start thinking, okay, but so why is it so, let's say, robust that can survive within the pipeline of production of our food and fermented food? Because obviously, very often we add additives that are preservatives. So how is it possible that they can survive out of that? And like in jam, marmalade, you have a lot of sugar. Usually this inhibits microorganisms to grow because it's too much pressure for growing. So then if you start thinking about that, maybe you can consider from a different perspective, let's put it in this way. And to add another image that I think is my favorite funny image, this yeast is so good in fermenting, very fast food, even when there is a lot of sugar, is that produce a lot of gases, and it can be even exploding can containing food. So this is another funny concept that I always found. And, so when I started to work with this yeast, I was thinking, okay, but is it dangerous? What happened when I start my kinetics? But then, as I said, I think it's very nice to think that if you consider that it is recognized as the most preservative resistant organism known, then you can think what these preservatives are. And could it be that we can turn, the coin to our favorite side? And this is what comes my story and also the story of Michael, actually, because we started to work together with this yeast. And we started to think, but can we turn this potential foe into a friend? And why am I saying that? Because Michael and we are really fascinated about the point that these microorganisms you mentioned before, you were talking about citric acid before. So these microorganisms can produce this chemical platform. This is what we call them, because, it's like these Lego pieces. And with these things, we can do so many things. And if you think about producing them from oil or from other fossil resources, then this means that you are depauperating the resources of the planet and producing, a lot of impacts on the environment while you are producing, while you are, let's say, processing them, and also at the end of life of these products. But if you think back about what I said before, that these microorganisms can really eat a lot of things, produce a lot of things, and then these things goes back to nature. So then maybe we can really think about it in a different way. And this is why we were thinking about using these yeast as a small cell factory and possibly engineering it, and then maybe Michael might have produced a lot of these organic acid that you mentioned before, because you can see they are different, but they can really go in different sectors that are really important for our society. So if you can convince this yeast eating, yeah, maybe we can think later on what this eating is, then you can produce a lot of organic acids, and then these you can use. And so this is what I somehow meant. The message was that very often we consider microorganisms, let's say from our point of view, but our point of view very often is limited to the things that we are doing in that moment. But if we try to enlarge our vision and then to see, then yeah, then you can really even turn things in a different way, and you can learn a lot. And what I mentioned before is that, you know, you keep on knowing these yeast. And yeah, what I can tell you is that at one point we thought, okay, we understood. So we can start manipulating this yeast, engineering that. And then from our collection, we took out our favorite one, because, you know, these microorganisms have many different strains, and then everyone had his own favorite. But then it turned out that our favorite strain was a hybrid. And he was laughing to us, because every time that we were trying to engineer that at the very beginning, we were completely puzzled. And it's just because obviously his genome was like a mess. And this is where we are now. We understood that. So we understood another point. Let's put it in this way. And yeah, I mean, I think that this is, I can even skip. I mean, I think that anyone is a little bit like bored about having presentations, but I think that some images were nicer than my face. But the message is that it's really a way in which we are, let's say, looking at microorganisms. And also another thing that it's funny to think is that, for example, you have a microscope in front of you. Yeah, that is really the instrument that is, you know, it was the way in which von Leeuwenhoek made our unknown unknowns evident, because before we didn't know what we didn't know. And so you go really in the very, very, in the world of the very, very little. But then you can only understand microorganisms if you can have at the same time the very big picture. And this is also another lesson from one of, let's say, the more relevant scientists of our field, that is Winogransky. So he was saying you cannot understand anything if you bring one microorganism in your lab and you just look at these microorganisms isolated from everything else. And so I think that the lesson that I learned more from microorganisms is to always have like a narrow bell ringing against prejudice. And this is what I wanted to say.
I mean, that's part of why we're here today, is to try and remove any prejudice people have against microorganisms. So I wanted to know, you know, is this yeast, Zygosaccharomyces bailii, present in all pickled jars, or is it just we have found it in pickles and that's cool? Or does it love living with pickles, or would it rather be somewhere else?
Well, obviously this I cannot really know, and it's even not the only one. It belongs to a genus where you have a lot of other yeast that are resilient against, for example, high concentration of salts. But what it is true is that obviously it might happen that during the pipeline of production, you have this kind of infection. And this is why they are really, let's say, considered like spoilage. And there is a lot of research actually trying to understand which their, let's say, weak points, because then when they start entering in the production chain, then you have, I don't think that, yeah, it's so common that if you have your own pickles at home, you might have that in. But yeah, it's also a story of competition, you know, because very often it was also found in fruit together with Saccharomyces cerevisiae. You mentioned it before. And so how they can cope with that. So Saccharomyces cerevisiae goes first. It ferments first, but then you have also some bacteria and they accumulate acids. And so Saccharomyces cerevisiae has to stop. And then this is when bailii comes. And so it's really a question of balancing and evolution, and also how they evolved. For example, sugar transporter, bailii prefers fructose. So yeah, and cerevisiae prefers glucose. So this is, yeah, nice story of how they can combine in nature and create niches. That is what makes our life possible.
Yeah, it's fascinating. I want to know, does this particular yeast, has anyone tried using it to brew anything or to make products that we could drink or eat or anything like that?
Well, yeah, there is something around. Actually, there was a company in one of our European projects that was interested to try something. Also because you know that, yeah, there is a moment, some concerns about the fact that because of the climate change, a lot of times that you have grapes, when they are good to be collected, then they have a very high ethanol content. So you might be interested in brewery or in winery, I don't know the term, in producing wine with some yeast that produces not so much ethanol as cerevisiae. And so bailii is something in the middle, let's put it in this way. So there is some interest, but at the very moment, I don't think there is a product produced with that.
Okay, well, maybe one day. And I wanted to know, is there a thorough understanding of the mechanism it uses to remain hardy? Or are there parts of it that are still under investigation that a young scientist could decide, this is my thesis area?
Yeah, I mean, if someone is thinking about that, yes, please come to my lab. Because yes, there is still a lot to do. I mean, I think that it's also good that I think that this day has been promoted by the University of Lisbon. And there is a professor that is Isabel Sacoreia, and she is one of the most, one of the experts on this yeast, and she worked also a lot. And so it's also, that is also nice because phenomena like robustness are something that we as scientists define like emerging properties, which means that are properties of the system. So if you isolate the single pieces, you cannot understand. So you understand one part of the problem, but then you cannot reproduce it. So this is the beauty. So you just have to understand how the different pieces belonging together then develop this trait. And this is robustness. So there is something related to the membrane. There is something related to some enzymatic activities that preserve something. There is something related to some specific transporters of ion, energy, and yes, but there is still a lot. And then when you come to hybrid as our favorite, what you also see that then they start to recombine the traits as for the Pastorianus that you mentioned before. And this is also something that we are at the very moment investigating, because then the two genomes contribute differently under different stressful situations. So yes, there is a lot to do. So yeah.
Fantastic. Michael, do you have any questions for Paola?
Yeah, the point is, one thing that I wanted to talk about, so you talked about robustness, but the point is we are also very much involved in microbial stress. And, you know, like we talked that yeast can age, yeast can be stressed too. And that's very interesting. So can you tell us a little bit about stress in context of yeast cells? How can a cell be stressed? So how we are stressed, we know.
Yes. So the point is that, again, let's put it in this way. You can look at this question from, let's say, looking at yeast staying in nature, and then if you think about using these yeast as cell factories, as we want to do. So obviously, if we look at in nature, so we know already that they had to face stresses, and especially it's because of competition. So they have to try to find their own niche. And so their genome has already adapted, or the potential that was in the genome was already expressed to counteract this stress. And again, if we compare that to what is happening to us, is like really a moment when you acquire this kind of trait, is not a continuous moment. It's one of these jump off, it's like we talk a lot in this year about resilience. And so the resilience in principle is the capability to grow within the stressful condition, if you have some abilities. So it's really the moment in which there is something that emerged. And this is nice, because if we keep this concept in our industrial processes, then we know that we are stressing the cells in a way that is completely different from the stress that they have in nature. Because, for example, we want them to eat like, you can still hear me because my connection, it seems a little bit weak.
Ooh, I hope we get you back. Yeah, we've just lost you for a moment. But this is the way with live streams. As you have people jumping in and out from all over the world, you might expect a little bit of a technical delay, but I think we've still got you. Yeah, okay. You're back.
Good.
There she is.
Okay, sorry, but yeah. And there is also a thunderstorm. So here in Trieste.
Oh, wow.
Yeah. So then the point is, for example, when we go for industrial bioprocesses, we want to have something that is sustainable. So usually we want these yeast to eat what we discard out of our. They are not in ideal condition, because maybe we want a specific temperature, pH, or whatsoever. And then we want them to produce one specific product at a very, very high concentration. So it's really something that they are not used to. So it's all a stress. And so if we manage to balance in a way that the stress can evoke something that is in the genome without killing them, so then maybe we can make one of these jump and produce something that was hidden in the genome, but we can, let's say, make appearing with our processes. I don't know if I was, that was in the direction of your question, Michael.
Yes, exactly. The point is that's very similar to what happens to us, right? So instead of roaming around in nature and be happy, we are sitting in an office under really unnatural conditions, and we should be productive and, for example, write a single report all day long. And so then still people think we should be efficient. So that is stressful. And that's exactly what we do to our microbes.
Yeah. So we're living in our equivalent of a strange petri dish, I suppose.
Exactly.
So I just wanted to move us into the final part of the breakfast show, which is when we're going to discuss fermented foods. And one thing I wanted to share, because it is so relevant, is that we have a blog on the FEMS website, in the FEMS Micro blog, called What's in Your Kombucha? So kombucha is this fermented tea drink, which comes from the East. And one of the things I wanted to draw our attention to is the microbiome of kombucha. So it is a yeast bacteria hybrid, or a mixture. And the kind of slimy, rubbery surface gloop that forms is usually called SCOBY, which I think is an anagram for something like surface, blah, blah, blah. I can't exactly remember it. We can Google that in a second. But one thing I wanted to draw your attention to were the species that they find. So there was a study put together here which I think we might get. But anyway, and they looked at the different species in kombucha. And this study found Candida was the highest prevalence, but in another study, they identified many fungal species, including Zygosaccharomyces bailii. So it sits there in our kombucha, helping to ferment this tea into a delicious drink. And then another one, which I have a lot of love for, is Schizosaccharomyces pombe. And the reason I love this particular one is the name. So this species of yeast was discovered in East Africa, and pombe is the Swahili word for beer. So that's why it was named Schizosaccharomyces pombe. What are your guys' favorite fermented foods or drinks? I mean, kombucha is kind of a new one. We looked at yogurt earlier on in the breakfast show, and I just had one more thing to show you about yogurt, which is to remind everybody that for International Microorganism Day, we have had produced a wonderful set of education resources. Can you see this now on your screen? Yeah? Okay. Including how to make your own yogurt at home. From last year, we had how to make sourdough, which Michael and I discussed in the previous breakfast show. Here we're using, I think, baker's yeast to kind of proof the dough and turn it into a sort of more acidic dough. But here we have instructions on how to make yogurt. So you need a very simple set of things, a little bit of yogurt, and then you can use this with your class. So, I mean, if you're a teacher waking up today and you haven't got a lesson plan, here's a nice way to teach your children about yogurt. So we talked about yogurt earlier on. We've talked about kombucha. We mentioned cheese a little bit earlier, but, you know, what are your guys' favorite fermented foods? And I have a few blogs as well from the Microbites initiative, which dig into this, but I just wanted to check with you, what could you not do without in terms of the foodstuffs that we love?
Oh, that's very difficult. You're always asking for difficult choices.
I know. It's to make you think and select.
Well, I can select only one.
I'll let you have two.
So if it's two, I would say it's cheese and beer.
Okay. And Paola?
If it's two, I would say cheese and bread. And for me, there is an additional challenge because it turned out in 2013 that I am celiac. So then there is also a lot of research in that because the flavor without gluten are more difficult to brew, to bake, and to make a dough that is anyhow excellent as the one that you have with gluten. So I think also this is a very nice field of research.
So do you still eat bread?
Yeah, yes. I mean, that is something that I would not call bread.
Yeah, that's a question of debate if she's eating bread or what that is.
Do you just have to limit the amount you take? Yeah.
Yes. But anyhow. Yes, so bread and whatever is around bread, let's put it in this.
So we just lost you for a second, but I think we've got you back. So again, we heard from the Microbites initiative earlier on in the call, and they have a series of wonderful blogs actually on sourdough bread and its aromatic microbes. And this is the process that we know and love now about making sourdough, a big craze during lockdown, but it produces all of the gas and raises the sourdough bread. And we have here a nice little infographic on, I guess, both our foods involved beer and bread from your choices. They all use Saccharomyces cerevisiae.
So at this point, we are still looking at the yogurt thing.
Yeah, well, we have it over here. Wait, sorry then, I haven't switched over. This is always the way with all the windows I have available. Here we go.
Yeah, there we are.
So this was the Microbites website. Maria from earlier helped put together the Russian section, which unfortunately I can't read, but it looks very nice. There's no Italian section, Paola. I'm sorry. Maybe you could help them put together one. But yeah, so we have some nice infographics here about creating sourdough and the active starter culture. And yeah, a nice little infographic about Saccharomyces cerevisiae. So there's some cool facts here. And I mean, its age of use is fascinating. So if it dates back to 7,000 BC, it's been used for over 9,000 years, which is probably one of the oldest microorganism-human relationships that we've cultivated. And not only do they have it on sourdough, they have it on cheese, which I think you both chose as one of your favorite foods. So there's plenty of information here. And then there's a few more interesting and perhaps lesser well-known facts about fermented foods. One I found very interesting was that you have to be careful about bacteriophages, because if too many bacteriophages get into your culture, they can kill off all the bacteria. Now, I know that bacteriophages affect bacteria, but Paola, is there a yeast equivalent? Is there some kind of yeast virus that you have to be careful of when you're looking at brewing things with yeast? Or do they happen to, have a little bit less vulnerability to viruses? Ooh, could you hear me? I think you might have frozen. Michael, do you know the answer? Oh, we've got Paola again. Yeah.
Yeah. Yes, no, they are less sensitive to that. Usually this is typical for bacteria, but then this is usually one point that is in favor of the people that work with yeast when they suggest to use them as cell factories for production, because they are less sensitive. So usually, really, this is something that distinguishes bacteria and yeast. And let's say implemented yeast, there are no, let's say, examples of phages that attacked that. So, but again, also, yeah, I mean, I think it's the very moment anyone knows, but also the story of phage infection turned into something that we now can use, because the story of this immune system that the bacteria has against the virus turned into the discovery of the CRISPR system. And so now that we know that together with these endonucleases can be used for targeted editing of genome. So again, it's another example of something that can turn into something useful, or something that can open our mind to new things.
Okay. So yeah, in yeast's favor, their ability to survive viruses, which is a bit better than bacteria then.
Yeah, it is relevant. So for example, like after World War II, there were a lot of fermentations for butanol production with bacteria. And so there were different reasons why we are not doing it anymore. But one of the reasons was phage infections, because if a production plant was once infected with a phage that would kill the production organisms, it would be hardly possible to take this plant into action again, because they couldn't get rid of these phages. They would always disturb the production. And that actually does not happen with yeasts. So for example, for baker's yeast, I don't think anything is known that could do that.
No, okay. Never heard about that.
That's nice. Good, healthy yeasts. We had a talk last night by John Warhol, and an initiative he was trying to get off the ground is the idea that every location should have an official microorganism. So I wanted to know, Paola and Michael, in the area you're in Milan and Vienna, where you normally are, Michael,